Now, in this lecture, I will discuss some difficult type of double integration involving different rules. Like this is the 15.17 question. If you see this question, you have to integrate with respect to dx, right? And the x function is in the denominator. And we feel it difficult. Once we feel, suddenly we see this, we see, and we think it's a difficult question. So it is not a difficult question because whenever we have a complicated any integral, you have to think about substitution method. So what happened in substitution method? We have a relation of function and its derivative in the integral, right? There's something, the function and its derivative present in the functions, right? And we do this, we let the function be u and the derivative will be du. It is dx with this, right? So here we can say we have to integrate with respect to x, and we have the function of x is 1 plus xy. So let us consider only this integral, the interior one. Now I will let it, I just consider this box, right? And I try to make substitution separately in this box. Then 1 plus xy bu. Then we take the differential. Differential of 1 is 0. Y remains same and the differential become dx and this is du, right? And what we get from this calculation, dx is equals to, y dx is equals to du, right? So this question turned out to be, if I just not convert the limits, and it turns out to be du, y dx become du, and this is u. So, so what we got, that in the denominator it is a function and the numerator it is the derivative, right? So it is the relation of like this. The function is in the denominator and the derivative is in the numerator. So whenever we have a function in the denominator and a derivative in the numerator, it turns out to be natural log of u. Okay. So by this calculation in this question, you can simply do the substitution orally, or if you are not good in substitution, you can make this box and do it like this, what I have done. So we come back to our question, right? So according to this question, I have let it equal to u, 1 plus xy, and then dy dx become du, and this is my answer. So I replace u with its original value. It is 1 plus xy. Okay, natural log of 1 plus xy, right? So we go to the question again, back to the question, right? Now I do it more quickly. The question is 0 to 1, 0 to 1, y 1 plus xy dx and dy. Now I will do the interior integral first. Okay. Now the y dx is the derivative and 1 plus xy is the function. This is the function, this is the derivative. So we have natural log of xy, right? And dy with the limit 0 and 1. Okay. Now I will apply the limits. Limit is natural log of 1 plus, I will apply limit on x because I do integration with respect to x. So natural log of 1y minus natural log of 1 plus 0y. dy. So the numerical result will be natural log of 1 plus y minus natural log of 1, because 0 into y becomes 0. So more we have natural log of 1 plus y minus natural log of 1. Natural log of 1 is 0. So we have with only natural log of 1 plus y. So I will integrate this now. Okay. So we will move forward. So now we will left with calculus 1 problem to integrate natural log function. So as you know, whenever we have natural log function in calculus 1, we do integration by parts, right? And when we do integration by parts, natural log of x is the first function. It is the first function, and this is the second function. And by integration by parts, we get the result x plus natural log of x minus x. So in calculus 2, you can directly apply this result here, right? So when I directly apply this result here, I will replace x with 1 plus y. I will replace x with 1 plus y. So the integration becomes 1 plus y, natural log of 1 plus y minus 1 plus y. Now you will apply the limits and you get the answers, right? So I will complete this. 1 plus 1, natural log of 1 plus 1 minus 1 plus 0, natural log of 1 plus 0. This is the upper limit, minus 1 plus 0, natural log of 1 plus 0, minus 1 plus 0. Okay, I just applied this limit. Sorry, I just second time correction. It is minus 1 plus 1 minus 1 plus 0, right? Now it becomes 2 in natural log of 2 minus natural log of 1 minus 2 minus 1. So natural log of 1 is 0, and we get 2 times natural log of 2 minus 1. So this is the answer. So all you learn in this question is to how to apply substitution method when we have double integral, right? And the integration by parts. Integration by parts is very important while doing calculus 2 problems. Most of the questions solved by integration by parts. First, you check substitution method. If it failed, then you apply the integration by parts method.